All right, so we're revisiting arithmetic sequences today, which is good, but we're also going to talk about when you want to add up a bunch of the terms, okay? So that's called a series or a sum of some part. We're going to do some of it on the calculator, so let me turn that on while you're all getting ready. Are we ready? Okay, so the learning targets are to find what are called arithmetic means. Basically, it just means missing terms, okay, between terms of an arithmetic sequence, and find the sum of an arithmetic series and solve application problems. So this formula right here should, or form, or what is this called? Which, explicit or recursive? This is this exact thing is on your gray sheet. Yes, this is the explicit. Oh my goodness, I think I need a cursor so I'm not writing all over the place, huh? Still don't have cursor. Hello. I don't know. Oh, there it is. Well, it was for a second. What's happening? All right. It does say arithmetic sequences have a constant rate of change. We talked about that. They would graph as a line. Explicit formula is the form we had up there, okay? It says if terms other than a sub 1 is given, the explicit formula for the nth term needs to be adjusted. Yeah, we're only going to use what we have. All right. Still trying to figure out what's happening with my cursor here. Maybe I have it. I don't know. All right. So this is just kidding. This is explicit. Arithmetic means are terms between two non-consecutive. So if I know I have, it'll say find two arithmetic means between 6 and 11. And it means there's two missing terms in an arithmetic sequence. Okay. We'll practice that in a second. So this one says find the 38th term. So this is review. Can anybody say how we might do that? -7 is the first term, right? We're also going to need to know the difference. What's happening, guys? The difference is +2, +2. Oh, I don't know why I wrote that twice. Sorry. Now, how do we find the 38th term? -7, 2, yes, times 38 minus 1, or 37. Let's see, 37 times 2 would be 74 minus 7, 67. You know me and my subtraction. It's a struggle. We good? All right. So again, two non-consecutive terms are known. The terms between them can be calculated. They're called the arithmetic means. So in this sequence, 17, 27, and 37 would be three arithmetic means that fall between 7 and 47. So it just means missing terms, okay? So write an arithmetic sequence that has three arithmetic means between 3.2 and 4.4. Okay. Anybody have any ideas how we're going to get those three missing terms? What do you think? Yes, that's right. Can you explain how you were thinking about that? This is my thinking. What you said is perfectly right, Madison. This is my thinking. I say to myself, well, to get this one, I added one difference, two differences, three differences, four differences. Does that make sense, guys? So 3.2 plus 4 differences gave me 4.4. Then we're to exactly what Madison said, right? Subtract, divide. Okay? She just was able to think about it without writing it out like that. I hope by writing it out, I help some more of you think about how it works. I'm getting 0.3. Is anybody getting 0.3? Okay. So if we add 0.3, we'd have 3.5 is the first missing one, 3.8, 4.1, and 4.4 would be next. This is kind of self-checking, right? Because if you get to the end and the next term isn't right, something's wrong. So the trick is when you see these, we're going to eventually do geometric means as well. So you have to keep straight, like, was I multiplying over and over and over, which would be a power, right? Or was I adding over and over and over? Okay. Find the first term of the arithmetic sequence for which this is true. Anybody talk me through this? Yes. Okay. Could I have said the 15th term is the first term plus the difference 15 minus 1 times and kind of filled in the numbers? The same thing that he's doing here, right? 30 equals a sub 1 plus 1.4 times 14. So then you subtract. Same thing. Just want to make, some of you are more like I need the formula. Some of you it just makes sense. Answer, anybody? 10.4? Thank you. And that was the first term we were looking for. Okay. Are we good? Find D. These are the kinds of questions that are definitely on the quiz, okay? Find D in the arithmetic sequence for which a sub 1 is 6 and the 40th term is 142.5. What are you thinking? Yes. A sub 1 is 6, a sub n. We have this formula. And if we're going to put in a 40 here, 142.6, we'd have 6 plus the difference, 40 minus 1 times. So minus 6 and then divide by 39, which is where Ian was going straight to that. 136, it comes out 35 after you divide? Is it 3.5? Okay. We good? Haven't done anything too new today. I guess the word arithmetic mean was new, but not too complicated. One more? That's kind of reviewy. Oh, find n. What do they want us to find? What is this asking? Yeah, what term number is 27? So negative 12 plus 3 differences. No, the difference is 3. 3 n minus 1 times gave them 27. So we're trying to figure out. 27 plus 12 would be 39. I'm not distributing. I'm just going to divide. Is that okay? I got 14. 14th term. Or just n equals 14. I just want to make sure you understand. Too fast? Not for some of you. I don't think I put one like that on the quiz where it asks for n. It's not hard, but. All right, another arithmetic one. Why don't you try this one on your own? 3 means between 17 and 39. Did I get them right? Did you get them right? Is anybody lost? It's 5.5 if someone used the decimal. And you could have written these as fractions if that was your joy in life, but it's really okay to give me decimals. We good? Write an arithmetic sequence that has 7 missing terms between -2 and 16. Have we learned anything about how this is going to go? How many differences are we actually adding? 8 differences to get to 16. So we get 18 divided by 8, which is 9/4 or 2.25. Did I do that right? Yeah, so then we just throw them all in there. Let's see, this one would be 0.25, is that right? 2.5, 4.75, how am I doing? 6, 7, is that right? 9.25, 11.5, 13.75. Okay. You can expect that it's going to be something kind of funky on the quiz. It's not going to be add 2 every time, just because I don't want you to just be guessing. I want you to be thinking about this, okay? You know, the sequence I give you on the quiz is not going to be 2, 4, 6, 8. Just because I want to know, can you really do this, not guess. All right. There are 2 formulas given by your book for finding the sum of a finite arithmetic sequence. Okay, break those words down for me. Finite arithmetic sequence, series. Do you remember from Friday? It's a long time ago. Arithmetic means that there's a common difference. Series means it has plus signs in the middle, that you're adding the terms. Finite means you're adding like 6 of them or 8 of them or 12 of them, okay? Not infinite, goes on forever. All right. The formula, oh, I love this. If this is the formula, if this is a sequence, and I want you to go out to, oh, let's see. Right? Are we good? What does this add up to? 308 and 2 is 310, right? 5 and 305, 310. 8 and 302, 310. Okay? So if, for example, I asked you to add up the first 100 numbers, so I said add up 1, 2, 3, through 100. Well, 1 plus 100 totals 101. 2 plus 92, plus 99 totals 101. Okay. So if you add the first and the last, you're going to get the same thing over and over and over. And if I'm adding, if there's 100 numbers, how many pairs of those am I going to get? 50 pairs. So n over 2. Does it kind of make sense where this comes from now? Okay. You're adding the first and last term, and you're basically averaging them times how many there are. Okay. This formula is, if you don't know the last term, you can plug this in, but it's just a combination of the 2 formulas we already have, so I didn't give you that one. because you should be able to do it. All right. So this is off your notes. It says this is what you're going to be given on the gray sheet. Find the sum of the first 50 terms. Now, this question is really easy because they gave us the first term, they gave us the last term, and they gave us how many terms they want us to add up. So the sum of 50 terms would be 50 over 2 times 11 plus 158. They told us the first term, the last term, and the fact that there's a total of 50 of them. So we get 25 times 169. Yep, no idea. One, two. Oh, can't hear. Someone else get that? Okay. Again, if you added 11 in this one, you'd get 169. If you added 14 and 155 that came right before that, you'd get 169. And because there's 50 numbers, there's 25 pairs that add up to 169. All right. Find the 23rd partial sum. Okay. This time, what don't we know? Well, first of all, is this vocabulary okay to you? Just means the sum of the first 23. Okay. And what don't we know? We don't know a lot of things. We don't know the difference or the 23rd term. Well, we can figure out the difference because they told us it's arithmetic. So it's going down, is that 9? 11. 11? I always get those. Okay. So the difference is negative 11. How do we find the 23rd term then? So we'd write 173 minus 11, 22 times. Yep. Yeah, don't know what that is. 69. Okay. Now what? Yeah, we have the number of terms divided by 2 times the first term plus the last term. I will tell you what seems to confuse students the most is what goes in here for n. I don't know why, but they start doing some crazy business. They are pretty good about remembering I got to have the first and last term. So 173 and negative 69. But then they forget this just means the total number of terms. So 23 over 2. Right. 173 minus 69 times 23 over 2. 1196, anybody? Okay, so that's called the 23rd partial sum, or just the sum of the first 29 terms of that sequence. Pretty easy? All right, so find the 82nd. Can you try this one on your own? When you're doing this in your calculator, be a little careful because this one's a negative, right? And this one's a minus or plus a negative. And this one's a minus because they're different keys. Anybody find the 82nd term yet? That's what I got. So now the sum what'd you get for the partial sum, Adriana? Good job. I agree with both of you. We doing all right? No? Are we okay? I got people still typing. I don't know if I typing something wrong. Are we good? Okay. Okay. Easy one or hard one? Really easy one, right, again? Because we know the 1st and 25th. I mean, I guess I'm assuming it's the 25th term because certainly the way they've notated it is. So times 25 over 2. $10.75, anybody? Good. Okay. They didn't give us the 53rd number this time. What's our difference? 852 times to give us the 53rd term. Anybody get the 53rd term? That is what I have. So then how do I find the sum of 53? Anybody got this? I'm not good about always writing the formula in the same order. I apologize. I should, but 11,660, anybody? All right. These have all been nice whole numbers. I kind of feel like they're not always nice whole numbers. All right. This one, just to review, you think we could find these buttons? Where's the word sum if you had an older calculator or you couldn't find that summation symbol? Do you remember where to find the word sum? Anybody? That for the summation symbol, yes, but the word sum is second list and then arrow to the right twice, and you find sum, and then it's second list, arrow to the right once to find sequence. And if you had a really old calculator, you'd then have to write 3n plus 1, comma n, comma 3, comma 15. On this one, if I was doing it without the summation symbol, I'm just going to do this once, and then I know you're all going to cheat and do it the other way, but it's not cheating. I'm fine. I don't care which way you do it, but I just want to remind you of the steps to find the sequence. Yeah, just kidding. That's not the right button. There we go. The sum of the sequence, 3n plus 1, comma n, comma 3 through 15, right? Is that what they have? I got 364, yes? Okay. So it's under math, up arrow a couple times to find the summation, or it's alpha window, and if you have the shortcut, it's number 2 there. If you want to type it in just like this, right? Start 3 here, end 15, and step you don't need. You can put a 1, but you don't need it. So if I put it in this way, I will go in the little box. What's happening here? N 3 15. If you were doing this one by hand, it would be kind of miserable, well, not that miserable, but because it doesn't start with term 1. We good? So what if I didn't, well, this one says use the formula. If I put in a 1, I get out a 2. I put in a 2, I get out a 4. I put in a 3, I get out a 6. So what would the 42nd term be? Do I already can put in a 42, right? The 42nd term would be 84. So now if I wanted, the sum of 42 should be the first one plus the last one. All, how many terms was it? 42. So I should have 86 times 21. Is that what you all got when you typed it in? Because I know you all did it with the sum symbol already. Because you love that your calculator does that. 1806, is that what you got? Okay. Word problem. Wakefield Auditorium has 26 rows. The first row is 22 seats, and the number of seats in each row increases by 4 as you move back the auditorium. So the first row, the second row is a little longer like this, okay? And it says the first one has 22. This would be 26, 30, blah, 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 all the way for 26 rows. Okay. How many seats are in the last row? Okay. How do we find the last row? Okay. What's the first row? How much are they going up by? And how many times did it go up? 25 times, right? 122, is that right? In the last row, there's 122 seats. Well, I hope there's some aisles get in there, because if you have to crawl over 126 people, 122 people, that'd be a problem. What is the seating capacity? What is this asking? The sum of what? All 26 rows, yes. First row, last row, 26 over 2. So 144 times 13, 1872, anybody? I remember it well. Everybody good? The first year salary of an employee is $34,500. Each year thereafter, her annual salary increases by $750. What will her salary be during her 10th year of work? This is one of those where you could decide, is this year 0 or year 1? Okay. Let's do it on our calculator for fun. See if we remember how to use this. Can you put your calculator in sequence mode? This wouldn't be a question you would need a calculator for, but let's do it for fun. Okay. Her first year salary is this, right? So we'll call that term 1. Is that okay with everybody? Okay. So up at the top, I'm going to change minimum term number to a 1. What goes in the second row?
Wait, no.
Yeah, in the U sub n min, the go down 2, and then it's 34,500. But here we need a formula. Can anybody help me? Do you want to write recursive, or it doesn't matter? Yeah, we could say, if we wanted to put it in as a recursive formula, we could say the last year's salary plus 750, right? So let's do that. Let's put, you remember how to get that special U?
No.
It's above the 7, second 7, and then just regular parenthesis n minus 1, close parenthesis, plus 750. Okay, now go to your, I'm going to go to table set, make sure it's auto, starts at 1, goes up by 1, okay? So now if I go to my table, the first year she made this, the second year she made this. So the 10th year, 41,250. Are you getting that? So otherwise we would have said she started at this and she's gotten only 9 raises, right guys? Because her 10th year. And that should be the same answer, I hope. Okay. So this is her 10th year. What will her total earnings for 25 years of work be? Now what do you want to do? We have to find the 25th term, so either scroll down for a while or add 24 raises. Okay, I made that look confusing. It's the other way around, 750 times 24, but all the same difference. Oh, well, if you put them all in as pluses instead of, or as times instead of a plus in the middle, you get a really big number. I wish they would multiply my salary by $34,000 times. I still typed it wrong. Oh my goodness. Anybody get the last year? No, is that right? Oh no, now I have it. Okay, so the 25th year's making 52,500. Is that what you got? Okay, so it's not really very exciting. A flat 750 a year is, with inflation, is probably not going to cut it after a few years. Might feel good the first year, but all right. Now we need what? The sum of 25 years. So we got to say the first year plus the last year. That's the 10th year. And 25 over 2, right? Okay. And I'm sure someone will get that right long before I can manage to type it in right. Is it over $1 million? 108,750. Okay. Goodness, I wish I had every penny I'd ever earned. I don't know, but the first year I taught, I made less than $17,000. So yeah. No, it wasn't in this district, but it doesn't matter what district it is. It was 1987, so nobody was making very much. But the top of the scale at that time was like $30,000. So, all right. So page 605, and this is copied in that set of stuff. Yeah, it's on the assignment sheet page. Okay. Yes, the homework check packets.